Assalamualaikum and good evening everyone. My name is Atira and I'm from group A25, and our group will be presenting on activated carbon adsorption, isotherm, kinetics and continuous flow operation. We did the experiment through sets of instructions which can be found in the methodology section by using the appropriate apparatuses. We determine the values for absorbance by using spectrophotometer. From the absorbance obtained, the concentration values can be determined from the calibration curve for methylene blue in the appendix. At the end of the experiment, we came to the conclusion where our objective is achieved. Activated carbon, methylene blue solution achieved an aquarium in 10 beakers, which the concentration decreases appropriately at 27 degrees Celsius. Due to its high degree of microporosity, only 1 gram of activated carbon has a surface region in overabundance in 500 meters square, as detected by the gas absorption. So I will elaborate more on the introduction. So adsorption is basically an unit operation where surface active materials are removed and transferred from the true solution solvent by interface transfer to the surface of adsorbent particles. One or more component of a gas or liquid stream are observed on the surface of a solid adsorbent and the separation is accomplished. So the theory on our experiment, activated carbon is a highly porous carbonaceous substance with a wide range of applications in gas, vapor and liquid treatment. Adsorption efficiency decreases over time, and eventually activated carbon will need to be replaced or reactivated. Isotherms are empirical relations which are used to predict how much solute can be adsorbed by the activated carbon. There are 3 isotherms which we use in our experiment. The first one is Friend-Rich, second is Landmer, and the third one is Linear. And our objective of this experiment is to investigate the adsorption properties of activated carbon by studying the equilibrium isotherms, adsorption kinetics, and operational characteristics of a lab-scale packed bed reactor. So I will pass the floor to my groupmate Shazwan to elaborate more on methodology. Thank you.
Hello, my name is Muhammad Shazwan and I will explain about methodology in this experiment. For the apparatus, we are using volumetric flask, laboratory shaker, mass balance to weigh the activated carbon, glass column, spectrophotometer to detect the absorbance of methylene blue, stopwatch, solution holding tank, salted tubing and glassware. For materials, we are using granular activated carbon and methylene blue. For the procedure in part A, absorption kinetics, 1 liter of methylene blue solutions were prepared in 3 beakers at the following concentration: 10 mg per liter, 30 mg per liter and 60 mg per liter. Next, the solution were placed over magnetic stirrers. At time equal to 0, 100 mg of granular activated carbon were added to beaker 1, 250 mg to beaker 2 and 350 mg granular activated carbon to beaker 3. Next, samples were taken at 10 minutes time interval until equilibrium in the system was achieved. The remaining methylene blue solution concentration were determined by utilizing the concentration calibration curve. For part B, adsorption equilibria, 100 ml of 125 mg per liter methylene blue solution and 10 different weights of granular activated carbon were added, starting from 15 mg to 200 mg to 250 milliliter beakers. Next, the flask were agitated vigorously using laboratory shaker until the system in each flask equilibrates. The remaining methylene blue concentration for each flask were measured using spectrophotometer. And finally, the quantity of methylene blue that was transferred to the surface of activated carbon for each flask was calculated. Then I will pass to my friend to explain about results.
Now I'll proceed with the results. My name is Lam Jin Hui and my metric ID is 16348. As you can see, our results are the results that we obtained from the experiment. We tabulated it in the form of tables. And for the first part of our experiment, which is about absorption kinetics, this experiment lasts for 50 minutes, and each 10 minutes a reading is being taken. And the first table here shows the results for the readings for the absorbance, and the second table here shows the results for the concentration. This concentration of the methylene blue solution, we calculated it using the calibration curve y equals to 0.177x, in which y is the absorbance and x is the concentration that we calculated. And this is the initial concentration of the methylene blue solution. This is the amount of activated carbon added. As for this table, it's about concentration divided by the initial concentration of the methylene blue solution. And after that, we plot a graph of concentration over the initial concentration versus time. And this is the equation of the curve that we get. So to plot the graph of QE versus time, we have to calculate the QE. QE is the moles of methylene blue divided by gram of carbon. So to calculate QE, we use the equation over there. QE equals to C minus C naught divided by 1000 times 319.585 divided by A. And A is the amount of activated carbon added. As for part B, which is about absorption equilibria, this experiment lasts for 70 minutes. And same as before, each 10 minutes a reading is being taken. And this table here is about absorbance and also the amount of granular activated carbon added. The second table is about concentration of the methylene blue solution. And this concentration is calculated using the same calibration curve as mentioned before, which is y equals to 0.177x. And this table is about QE, and QE is also calculated using the same formula as before, as shown before, which is C minus C naught divided by 1000 times 319.85 divided by amount of granular activated carbon added. As for the Langmuir isotherm, we have to calculate C divided by QE, and this table here shows that what we have calculated from C divided by QE, and after that we plot a graph of C divided by QE versus C, and this is the graph that we plotted, and that is the equation of the curve that we get for the curve, and the constant for Langmuir isotherm can be calculated using the equation that we obtained from the graph that we plotted. As for Freundlich isotherm, we have to calculate the value for log of concentration and also the log of QE. And we tabulated both of them in the form of table. And after that, we plot the graph of log Q versus log C, which is log of concentration. And this is a graph that we plotted for Freundlich isotherm. And as the same as before, the constant for Freundlich isotherm can be calculated using the equation of the graph, the equation of the curve that we obtained from the graph. And now I'll pass to my friend to further discuss about the discussion of our results.
Hi, my name is Teh Hui, ID 16512. Today I'm going to present our discussion for this experiment. For part A, which is absorption kinetics, we have measured the absorbance of methylene blue solution samples at different times. The absorbance recorded is then converted into concentration using the calibration equation. In our experiment, the absorbent used is the granular activated carbon, whereas the absorbate is the methylene blue. The lower the absorbance indicates that there is lower concentration of methylene blue in the sample. It also means more methylene blue is absorbed to the surface of activated carbon when the absorbance is low. Generally, when we left the activated carbon in the methylene blue solution for a longer time, the contact time between the adsorbent and the adsorbate is longer. So more methylene blue is supposed to be absorbed by the activated carbon until the activated carbon is saturated. However, from our results, it is observed that the absorbance fluctuates. This might be due to errors or contaminations while taking the samples from the solution. Besides, it is also noted that the rate of absorption increases when the concentration of methylene blue is high, and also when there is more activated carbon added into the solution. When the concentration of methylene blue solution and the activated carbon are both high, more methylene blue particles and more activated carbon surface area are available. Thus, these particles collide at a higher frequency, increasing the chances of being absorbed to the activated carbon surface. And this is how the rate of absorption is increased. Next, from the graph of C over C naught versus time, the concentration fluctuates with time, and this is due to the error that I've just mentioned before. Nevertheless, the last few readings show that the concentration decreases with time and then increases again. This is because saturation of activated carbon has occurred, it has reached the breakpoint and desorption occurred. The surfaces and pores of the activated carbon are fully occupied with methylene blue, therefore it cannot absorb any more methylene blue particles, and this is where the breakpoint occurs. Similar trend is also shown in the graph of quantity of methylene blue transferred to the activated carbon surface versus time, which is QE versus time. The plot shows that the amount of methylene blue transferred to the activated carbon surface increases until it reaches the breakpoint where the saturation occurs, and then it decreases due to desorption. Next, for part B, which is the absorption equilibrium graph, Langmuir and Freundlich isotherms are both plotted based on the data acquired. As we can see from the graph of log QE versus log C, which is the Freundlich isotherm, the plot has negative gradient for all amount of activated carbon added. Therefore, the data is not well fitted to the Freundlich isotherm. On the other hand, from the graph of C over QE versus C, which is the Langmuir isotherm, positive linear lines are plotted for all amounts of activated carbon added into the methylene blue solution. The data fits the Langmuir isotherm, so we can deduce that the absorption of methylene blue by the granular activated carbon actually conforms to the Langmuir isotherm. That's all for discussion part, and now I'll pass the floor to Nitya to conclude the experiment. Thank you.
Good evening everyone, my name is Nityananda and my ID is 16315, and my part of this particular presentation is on error and recommendation. So all of us know each and every single experiment needs to be improvised. So in order for that, you have to find out the error and you have to know the ways to improvise it. Okay. When talking about errors, the general error that you can find in all the experiments are when you're measuring a water level on a beaker. So for this experiment is when we are measuring the water level measured at the beaker to prepare the solution required, it is not precise with the calibration line because we are observing the mark using our naked eyes. Besides that, when you look into the measuring solutions, the absorbent which is measured, which is using a sampling bottle, requires the solution to be filled up precisely at the 10 ml mark. This might lead to a parallax error, as how I mentioned a while ago, and also human error when we tend to move at each and every single interval time. Okay, when we move on to the next point is, for this particular action, we are using a next apparatus which is called as pipette. The pipette used to drain out the solution from the beaker to another sampling bottle, and each one-time interval, the sampling bottle need to be thoroughly clean. But well, in this case, it is not clean because it might have some unwanted bottle display which may influence the producing and the exactness of the absorbent. And coming to the final error of this experiment is the stirrer that we use to stir the solution. As we know, at each and every single university this year, we are using old machines. So when you tend to get old, how about the preciseness and the efficiency of the machines tend to reduce. So in this case, the stirrer that we use to complete the installation of activated carbon might cause some additional mistake in the reading because the speed of each stirrer is not uniform, which led to faster and slower installation according to the speed. Okay, let us proceed to the recommendation part. Since we have some errors, we have to give some suggestion on to improvise it. When you're talking about the marks that we are observing using naked eyes, In order to increase the closeness and the preciseness to measure the reading on the marks of the apparatus, the eyes must be precisely in accordance with the meniscus level. Besides that, in order for us to measure the absorbance of the solution exactly without any fluctuations in the reading, the pipette used must be thoroughly clean and right before utilizing it again. Finally, to tackle the matter of the speed of an old machine such as the stirrer for this particular experiment, the velocity of the stirrer must be consistent for each and every single beaker. Okay, let me conclude the experiment. Basically, adsorption is this. In adsorption theory and kinetics, the initial rate of adsorption is proportional to methylene blue concentration and the concentration of granular activated carbon. The adsorption of methylene blue utilizing activated carbon is classified well by Langmuir and Friendlich isotope models, yet the adsorption of methylene blue onto water heating take after Langmuir's model. An activation level is sufficient for useful application may be accomplished exclusively from high surface region. Nonetheless, further chemical treatment regularly upgrades and adsorption properties. Okay, let me conclude it with an example of given such as the factors affecting the activated carbon is normally determined from charcoal and progressively with high porosity. I think that is all from my group. Thank you so much.